and welcome to this video on the application problems for exponential functions. In this video I'm just going to work through 3 problems and we'll just see how they go. With these questions it's usually just a matter of pulling them apart and dealing with bits as we sort of encounter them. Just a couple of things. So most exponential equations will be of the form a equals a0 times some base to the power of t. So the thing is that this number here, it always represents the initial amount of something. Okay, so when we get into a question like this first one, the number of insects present in a colony is modeled by the equation n of t equals 48 times 2 to the power of 0.5t, where t is the number of days since the colony started to develop. Find the initial number of insects. So really, n of 0 is equal to 48. And I can show that mathematically because initial means like when time is 0. So we're just substituting 0 into that equation. 2 to the power of 0 is just 1, so it's 48 times 1, which is just 48. Find how many insects are present after 16 days. So n of 16 equals 48 times 2 to the power of, whoops, don't need a bracket there, 0.5 times 16. So I'm going to go to the calculator for this, just get rid of this other information here. So 48 times 2 to the power of, and well, half times 16 is just 8. So 12,288. Also with these questions, you know, it's a good idea to make sure that you answer to the nearest whole number. Like, it makes sense to do that in terms of this question at least, because we're talking about a number of insects. Find how long to the nearest hour it takes for the colony to reach 5,000 insects. So this time we have 5,000 as the number equals 48 times 2 to the power of 0.5t. I could go through this. I could divide by 48. I could then take the base 2 of everything and then divide it by 0.5, or I could just use the calculator. 5,000 equals 48 times 2 to the power of 0.5x. Highlight it, interactive equation, solve. And that's going to be interesting. It didn't write the equation in properly. So I need to put brackets around that. There we are. So 13.4. I might keep a few decimal places here. So t equals 13 point, what was it? 405. 4055 should do. And that is days. So the thing is, we need this to be to the nearest hour. So I know it's 13 days. But I need to figure out what 0.4055 of a day is. So 0.4055 multiplied by 24. And so we'll say 10 hours, as that would be to the nearest hour. And there we have it. So moving on. An exponential model of the form a equals a0 times 1.2 to the kt passes through the points 3,8 and 920. Find its equation to 4 decimal places. Okay, I'm going to go through this algebraically to begin with. So I'm going to substitute in the 3 for the t and the 8 for the a. So 8 equals a0 times 1.2 to the power of 3t. That would be the first equation. The second equation would be 20 equals a0 times 1.2 to the power of 9t. Now, looking at this, I need to have a way to solve these equations. And this is something that wouldn't have been done before, I would think. Usually with simultaneous equations, we would add or subtract the equations, but that won't actually cancel out any of the variables here. What I'm going to do to solve this is I'm going to do equation 2 divided by equation 1. Okay, so 20 on 8 equals, now the A0 divided by A0 will cancel out. And so I'm left with, actually I might even write it down just to make it a bit more obvious. So we've got A0 times 1.2 to the power of 9t divided by A0 times 1.2 to the power of 3t. So the A0's cancel out. 20 over 8 simplifies to 5 on 2. And we've got 1.2 to the 9t over 1.2 to the 3t. Now whatever you do, don't cancel out the 1.2's. Okay, we need to use our index laws here, and we know that when we have a number divided by another number, we subtract the indices. So that's 1.2 to the power of 6t. I can then take log base 1.2 of both sides. So 6t equals log base 1.2 of 5 on 2. And then divide it all by 6. So t equals 1/6 log base 1.2 of 5 on 2. Now that seems pretty horrible, and that's right, it is. Okay. Sorry, I've gone through this thing with t's instead of k's, so just change these to k's. That was my bad. Very easy to do when you've got so many letters all over the place. So, we've got the value of k, and it's an absolute mess. Much better way to do this question would be to use your calculator. We can set it up with simultaneous equations. So I'm going to just write them in. 8 equals x times, so I'm using x as the A0, 1.2 to the power of 3y. Make sure that all goes in the power there. And the other one is 20 equals x times 1.2 to the power of 9y. And I'm going to solve that for x and y. Just thinking for a moment. So I've got x, which is the a, and in this case, or A0, which is 5.0596. And I've got k, which was 0.8376. So as you can see, this is a much easier way to do it. Therefore, a is equal to 5.0596 times 1.2 to the power of 0.8376t. That would be the equation. Much easier than going through all this stuff here to get it. And the main reason I showed you that though was because I wanted to show you that process of dividing the two simultaneous equations. The last part, the decay of a radioactive substance, is modelled by that equation, where Q is the amount of substance in grams and T is the time in years. If the half-life is 240 years, find K to 3 decimal places. This is a little bit of a tricky question. So what we know is that when time is 240 years, the amount that's remaining is half of the initial amount. And so I'm going to substitute those into the equation. So the amount remaining after 240 years is half Q0. That's equal to Q0 times 1.8 to the power of negative 240k. We can divide both sides of the equation by Q0. So we get 0.5 equals 1.8 to the power of negative 240k. And again, I could go and take log 1.8 of both sides, but I'm just going to type this into the calculator. So 0.5 equals 1.8 to the power of negative 240x. And I'm just going to highlight it and solve. scientific notation. Just going to change that quickly, make that normal 2. Much better. So K is 0.0049, or K is 0.005 to 3 decimal places. So then part B, just put a box around that. If initially there is 2 kilograms of the substance, find how long it takes to lose 90% of its mass. Okay, so to do part B, we know that initially Q0 is 2,000, because that's 2,000 grams in 2 kilograms. So the other thing is that we want to lose 90% of its mass, so we only want there to be 0.2 of a kilogram left, or 200 grams. So I'm going to make it 200, because that's the 200 grams remaining after it's lost 90%, equals 2,000, that's the initial mass, multiplied by 1.8 to the power of negative 0.005 t. And again, I'm going to use the calculator to solve this, and I think this is the expectation. You know, you use your calculator to do most of these application questions. So 2,000 times 1.8 to the power of negative 0.005 times x, I'll call it, just replacing t, and highlight that interactive equation and solve. Didn't like that. Interactive equation solve for x. So x in this case is 783.48. So t equals 783.48. So find how long it takes to lose 90% of its mass, 783.48, and that was in years. Anyway, that's how we can work through those questions. It's been quite a long video, but as you can see, these questions can be a little bit involved, and each of them is a little bit different. You kind of have to really think your way through them, but just take your time with them, and always figure out what the question's actually asking you to do, and just go through it step by step. Anyway, I'll leave it there. See you next time.